Hi guys, this is the second time. Okay, today's topic is actually the absolute value functions graphing method. We have absolute. We know what is the absolute value sign, right? So, for example, if we have the original function of y goes to be fx, then how to draw y goes to be f of absolute value of x or y or goes to absolute value of no absolute value of y goes to be fx, or sometimes y goes to be absolute value of fx, or sometimes combination of those things, right? Yeah, today I will explain here how we can graph or those functions. So for example, okay, if we have y goes to be fx here, then the x-axis are there, and the y-axis are here, okay. Then the first thing, okay, I'll introduce, I'll explain is how we can draw the y goes to be f of absolute value of x. The first thing you need to think before you start to draw is where those two functions are exactly the same. The blue color, absolute value of x, and then the original function. Okay, where those two functions are the same. If x is positive, then the function inside the blue box and the original function needs to be always the same, right? So x is positive, which means there is this reason, right? So whatever graph which is belonging to this positive x-axis, then the is, yeah, exactly the same with the original graph, which means, yeah, the graph is here, right? Then if x is negative, then what happened? If x is negative 2. In this graph, if x is negative 2, that means y goes to be f of absolute value of negative 2, right? Which is actually f2, correct? So for example, okay, here we have 2. Then even though x is minus 2, y value must be the same with f2, correct? This is f2, right? F3, F4, yeah, everything on the right hand side, yeah, it will be exactly the same. As x it goes this way, then the opposite side, yeah, the graph goes this way. Yeah, the shape of two graphs must be symmetrical about the y-axis, correct? So that we just copy, actually symmetrically copy, you know. So it should be something like this. This is y goes to be f absolute value of x graph. It's so simple, right? So if you put the absolute value sign on the x, then you draw the positive side of original function, and then you just copy to the negative side of the x. Understand? Okay, then the second one is y goes to be fx versus absolute value of y goes to be fx. How you can draw this? Again, I have the same, no, not the same, but similar function. The original function is here. Then again, the first process is the same. Okay, where two functions are the same. Okay, in this case, I will draw with the red color. If y is positive, if the graph is above the x-axis, then two graphs must be the same because x and y, all those values are exactly the same, right? So this part, and then this much part, okay, the graphs are exactly the same. Am I right? After that, we need to think two things. Okay. First one, if fx is 3, then what's happened on this red color one? Absolute value of y goes to be 3, right? Then your y is, okay, plus minus 3, which means you have one y value on top of the x-axis, and then you have another value or another y value underneath of the x-axis. So for the one value of x, we have two y values, correct? And then if, for example, fx is negative 3, then what happens? Absolute value sign of y goes to be negative 3, right? No y value. Absolute value cannot be the negative sign, right? So original function, if the original function is underneath of the curve x-axis, then yeah, all those graphs will be disappeared. In this case, we don't have any y value at the end, right? But if original function is above the x-axis, then we need to put another symmetrical shape underneath of the x-axis because we have two y values for each of the positive fx, right? So yeah, this is the region. The red color one is y, absolute value is fx. I call this as a copy. Now one thing here is, okay, this is null function. We can draw the graph, but this is not a function because for each of y x, the single x value, we have multiple y values. Right? We don't call this as a function, right? Okay, then the next one, if we have absolute value sign on y as well as absolute value sign on x, then how? Again, I will draw the similar shape. What do we need to think at the very beginning? Yeah, exactly. What? Where two functions are the same. Since absolute value sign is on the x, on y, so both x and y must be positive so that two functions are the same. Right? Where it is the same? Okay, the first quadrant. Whatever graph, whatever portion of the graph of the original function y goes to be fx, in the first quadrant, x is positive, y is positive, then the two functions are the same, no doubt, correct? And then what we did, okay, since we have absolute value sign on x, then we need to copy this about the y-axis like this, copy. And then since we have absolute value sign on y as well, then we need to copy this about the x-axis. Yeah, definitely this is not exactly copy, right? But anyway, this is the result. Now it's easy, right? Can I say it's easy? And then another one, y is absolute value of fx. Okay, again, I have graph like this, where those two are the same. X is positive, and then fx is positive. Yeah, that is actually in original function y is fx. If fx is positive, then y is also positive, right? So that y is positive, x is y is positive, then everything is the same with the original function, right? Then, as we did here, I will do a similar one here. Okay, if fx is 3, then y is just 3 in this case. Yeah, we don't have minus 3, right? We have just only one value, y is 3. But if fx is minus 3, then what happened? Y is just what? 3. It becomes to be positive. What does that mean? If original function fx is negative, which is below the x-axis, yeah, this part and then this part, right? If original function has the negative value, then once we put the absolute value sign over there, it turns to be positive, right? So that it goes up like this. It's different from the copying because we are just bring this part and this part up here and then here, so that I say this as a fold up. So once we have the absolute value sign on the fx entire function, then yeah, we need to fold up whatever portion of the original function underneath of the x-axis. We just fold up. Okay. Then I'll give you an example. This is past paper question, I think. Fx is x minus 1 absolute value. No, x minus, no. Absolute value of x minus 1. Draw this. Okay, how to draw this? We have fx y equals to no, y equals to x, and then we have y equals to the absolute value sign of x, and then bring this down by minus 1. This is y equals to the absolute value sign of x minus 1. This portion is actually later. Yeah, I will make another session. This is translation, right? Translation by 0 minus 1. In other words, there is a vertical translation by minus 1, right? So that this is fx. Okay. Then what is the next question? Y is f of fx. How to draw this? F of fx, that is f of absolute value sign of x minus 1, and then we put this much into there, right? So that, okay, we have absolute value sign and minus 1. Inside this absolute value, we need to bring entire thing inside here. Then that is absolute value x minus 1. Well, how we can draw this? The thinking process is something like this. Okay, we had at the very beginning y is x. After that, we just put absolute value sign, and then we just put, okay, minus 1 after that. After that, we just put absolute value sign on the entire function. After that, we just put another minus 1 there, right? So original function was here, and then this one, okay, we fold this up so that it goes like that, and then we bring this by minus 1 so that we have like this, correct? This is up to the above function, right? After that, we put the absolute value sign there. So how? Because of this absolute value sign we put on the previous function, then we bring this on top. We fold it up, right? Fold up. Originally, the function was here, and then we fold up. After that, we bring that by minus 1. Okay, I will use the yellow color. Minus 1. Then the graph goes down by minus 1. So here, then here, 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 and something like this. 0, minus 1, 2, minus 2. That's the final graph, right? Can you draw this? Okay, then try to exercise one more time. Y is f of fx. How to draw this? f of fx. And we know what is that? F of absolute value x minus 1, absolute value minus 1. So then we bring these inside the bracket and then minus 1 right there, right? So absolute value x minus 1, minus 1, minus 1. put the color. This is pad paper. Okay, up to there we already know what is the graph shape. That was like this, right? After that, we put the yellow color absolute value sign, we fold up. So this one goes up, and then this one goes up like this. And then this part is remaining at the same. And then we bring down this by one. And this goes down here, this goes down here, this goes down here, 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 something like that. So that the graph shape goes like that. What is the coordinate? Minus 1, 1, 2, 3, minus 1, 2, minus 3. Okay, this was a good example about the how to draw the absolute value sign graph. Yeah, since we did the absolute value sign graph, the next example I can give you is how to draw the scale. Y is fx. Okay, we have this graph. Then how we can draw y goes to be fx squared. Okay, let's think. If we scale 2, then it goes to be 4, right? If we scale 3, it goes to be 9, so it goes to be increase. Alright? But how about this? If we scale half, it goes to be 1 over 4. 1 over 3 squared goes to be 1 over 9, or it goes decrease. In other words, I can say it is going further from 1, 0, okay. It's going closer, it moves closer to 0 origin, right? So if you have, okay, number line, if you have 0 here and the 1, whatever number here, if we make the square, then it goes to closer to 1. Whatever number out of 1, once we make the square, then it goes further away, far away from origin. This is the movement. This is the first factor you should know. Then the second factor what you should know is O and 0 and then 1 is kind of what? Invariant. Even though we make the square, it doesn't move at all. Correct? The value after the squaring, yeah, will be the same with the previous original value. The third one is negative goes to be positive, which means whatever number below 0, it goes to be positive side. So for example, okay, here we have one number. Then first we bring these to the symmetric side here and then make squared. Oh yeah. So the around there is this the final position. If we have another number, okay, for example here, then first we bring these to the symmetrical point here and then then make squared, it goes further away. Right? Yeah, those are the concepts. So for example, if we have the graph like this, again always the same graph. In this case, yeah, we don't need to have y-axis, but what we need to have two supplement lines like y equals to 1, and another one is y equals to be negative 1. I said 0, y is 0, right? And the y is 1. Yeah, those values are invariant point. And then once the value was minus 1, then it goes up to be positive one, goes up to be positive one, goes up to be positive one. Okay. After that, whatever value below y is 1, so what I mean is this, those reason. Actually, the after scaling, the graph goes down closer to the x-axis, right? Once we copy up the below function, then this is so-called the copying. Then after that, okay, we need to bring this area down like this, right? It must go closer to the origin. But above y is 1, it goes far away, further away from origin, right? So that it goes up like this. It goes further away, right? So if I continue to draw that, then this one around here, yeah, we have maximum. Minimum goes to be maximum. Yeah, this is y goes to be fx scale graph. Understand? The last one, y goes to be 1 over fx graph. The first thing, okay, if fx is 0, then it goes to be vertical asymptote, right? Secondly, if fx is plus or minus 1, then this is so-called invariant point. Even though we make the reciprocal of those functions, yeah, still the value is the same, right? Something like that. And then if fx is bigger than 1, it goes down. Fx is between the 0 and 1. If fx is smaller than minus 1, then it goes down to the minus 1 to 0. If fx is between 0 and 1, then fx must be bigger than 1. If fx is between minus 1 and 0, then it goes to be fx is smaller than minus 1. Which means that if we think this in the number line, we have origin 1 and 2, right? Whatever number here, once we make the reciprocal, it goes very far. Whatever number here, very near to 1, once we make the reciprocal, it is, yeah, above 1, but still very near to 1. Correct? The same phenomenon is here as well. Something like this. And then if the original function, original value was 0, then make the reciprocal, then we cannot define the number. So you just think those concepts. And again, okay, let's draw the same original function. And then we have y equals to 1 here. We have y equals to be negative 1 here as well. And then first, okay, once original function is 0, then there is vertical asymptote, here, and then again vertical asymptote there, vertical asymptote. Then one more vertical asymptote is here. And then if, okay, y is 1, or if y is negative 1, those values are so called the invariant point, right? Maximum definitely goes down to the minimum. Minimum goes up to the maximum. Then the graph goes like, just connect all those points smoothly. Understand? This is so-called the y equals to reciprocal function. Okay, so today what I have summarized here is okay how to draw a different the functions graph, and how you can draw the absolute value sign the functions like f of absolute value sign of absolute value of x, or absolute value of y goes to be fx, or the whatever, and then fx squared and then 1 over fx graph. See how to draw those things. That's what we have done today. Okay, today the lesson is up to here, and then tomorrow I'll be back here again with different another topic as well. Okay, good luck. Bye.